Hi, I'm Rich with insideHPC. We're here at SC12 in Salt Lake City. We're here at the Cycle Computing booth. I'm here with the CEO, Jason Stowe. Jason, I heard you had a good demo here. What's this about?
So basically what we've got is a few different technologies at work. We've got Cycle Cloud, which allows us to spin up these really large 50,000 core environments. Can be used for anything from life sciences to financial to insurance use cases to manufacturing and CFD. And what we do is we take these and make it so you can create them once your internal environment is full. So we have a feature of Cycle Server, our primary internal product, that's called Submit Once. It allows us to run between an external environment and an internal environment and move workloads between them and schedule the data without the user having to be aware of anything about capacity and whether or not this question will fit inside their internal environment. They can leverage cloud or leverage external other capacity without even thinking about it.
So it's all about flexibility and making people productive.
Exactly.
That's
exactly right.
Well, can we take a look?
Yeah, let's do that. So internally here we have a vantage point on a small cluster. We actually have two clusters running, an internal and external environment. And what this is showing us is compute capacity that's currently being used on an internal environment. So some of these nodes here are hot because they've picked up workload and are actually running. We can click on this and be able to go directly to a host page that shows us both what the profile of this machine is, as well as the current ganglia statistics about what's been operating and all the jobs that have run here over time. So you can actually see which jobs in particular have been completed by this host. So it's basically designed to allow you to do root cause analysis and performance visualization very easily from one central console. But then we have a command line interface that allows people to use their normal Q commands to be able to actually submit both to this internal environment, but when it's necessary, be able to leverage the external environment as well. So what Ian's just executed here is a QStat command, shows you everything that's going on inside the external environment, everything that's going on inside the smaller internal environment. And when we want to see, what workload we're going to be running, in this case we're running a blast application, and then we're going to see, can we simulate what happens in advance when I want to run a job? Is it going to run on an internal environment or an external environment? So if we submit a 100-job cluster, in this case, because our internal environment's small, it's going to actually route that to the external environment. When I submit a 2-job cluster, it's actually going to run this internally. So what we're going to do right now is actually just submit a 100-job workload and show that going both between the internal and the external. We'll actually separate up the workload and run it in both environments. So this QSub command is the standard user interface that everyone has with their cluster. And this job array, actually 2 of them went to the internal environment, and then the remainder went to the external environment. So we can now actually see QStat-wise that this is running on both, again, the external environment, and some of it's running on the internal environment. The user didn't have to do anything. Now, if we actually look at the disk space on the external environment, we'll see that this job actually got routed. So before, when we typed LS at the very beginning, there was nothing on this disk. But what's happened behind the scenes is our data scheduling technology has taken that data, moved it externally, and we now have an Andrew job directory that shows where the job is landed, and we have the exact same data in and executables that were present on the internal environment are now present on the external environment. And so basically this is routed automatically between these 2 different clusters. So essentially right here you can see the data was transferred from the internal environment to the external environment, and the user didn't have to know anything.
That's terrific. That's really impressive. So, I just wondered, where are these analytics running that I was seeing? Does that run, locally or on the cloud, or?
So we have a web application called Cycle Server that's actually pulling all those stats that you already have. So we plug into all the systems. If you have Ganglia running, if you have a scheduling system like Grid Engine or Torque or Condor or LSF, we pull all the data out of those environments and then pull that into the web UI that you saw earlier, Ian. So that's essentially being done through a web application that plugs into your existing systems in order to show you a heat map of exactly how your cluster is being used, what the current total memory usage is. If you mouse over any of these graphs, you can see exactly which users are currently using how much of your internal cluster.
Yep.
So essentially we have these all enabled based on the systems that you're currently using as an HP administrator. The HPC systems that you're currently plugging into would be the ones that we're basically leveraging.